In the space of science and monstrous favored experiences, the subject of what existed early on to the gigantic effect has mixed discussions and interested characters for a surprisingly long time. This Goliath demand doesn't simply test how we could unravel the universe. It challenges the veritable farthest objectives of human information. Envision remaining at the edge of presence, analyzing the enormous shadowing, and considering what lay there before our universe was envisioned. The occasion of the enormous detonation denoted the start of history, space, and what we know. In any case, was there a second sooner? Ahead of time, may there in the end have been a state of nothingness, a quiet before the ranting gathering began? And if this is real, was it? Or perhaps there was something fundamentally more disturbing that existed before time itself. As we jump further into this solicitation, science takes us on an excursion past the universe's early phase into contemplations that challenge our understanding. Physicist Brian Cox, known for his commitment to the wonders of the universe, proposes that something stunning could have existed before the enormous detonation. He moves us to re-examine our reasoning of the veritable world and existence. In this assessment, we'll explore the science, the hypotheses, and the amazing insider secrets that could figure out what existed prior to everything. We'll investigate ideas like genuine improvement, quantum changes, dark energy, and even multiverses. The responses we've uncovered may very well astonish you. However, they could also open new understandings of our position in the universe. Prepare to dive deep into a world beyond imagination and science, where the dark still lingers in the shadows, leaving researchers stunned, and sometimes even unsettled. We should examine what existed before the enormous detonation and why these speculations challenge everything we thought we knew. To appreciate what could have existed before the huge explosion, we first need to examine what the huge explosion was. The huge explosion, as researchers depict it, was the event when the universe became incredibly hot and dense, expanding rapidly to trigger the formation of all matter, energy, and fundamental forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies expanding outward from a single point. But what caused this to happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or calm. Cosmic inflation proposes that before the huge explosion, the universe was in a state that was cold, empty, and free, essentially like a primordial vacuum. However, this vacuum wasn't entirely empty. It contained an immense amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the foundation for everything that followed. In just a fraction of a second, space expanded at unimaginable rates until the expansion slowed down and the energy transformed into matter, particles, and the forces we associate with the enormous detonation. But what was the nature of this energy? Why did it emerge from nowhere to create the universe? And why did it stop? Scientists believe that this limitless expansion created patches of the universe, each undergoing its own enormous detonation. Imagine a fabric stretching infinitely, with tiny bubbles forming, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially infinite huge explosions in countless universes. Our own universe is just one of many. This vast, mind-bending reality challenges how we understand the universe itself and leaves us with the ultimate question: what else is out there? The idea of nothingness before the enormous bang is theoretical, not factual. However, based on our current understanding, even if you remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that make up an intricate tapestry of existence. Even in its most seemingly empty form, the universe contains energy and activity at a quantum level. Even if we imagine stripping away all these forces, leaving a void, the universe would still generate new types of energy. This reality is baffling to scientists, as it suggests that absolute nothingness may be impossible within our vast understanding. Space itself has properties, rules, and constants that prevent it from being entirely empty. Imagine creating a region with literally nothing in it, no particles, no radiation, and no energy, yet quantum fields and fundamental constants would still exist. This suggests that even nothingness has properties. For example, there is a concept called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still appear and disappear, creating a subtle but persistent fluctuation, even in what should be a vacuum. This challenges our very definition of a true void and suggests that even before the huge explosion, something existed. Scientists are still working to understand this phenomenon. One of the most astonishing theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it is possible that it could continue indefinitely. Brian Cox describes an incredibly vast inflationary multiverse where universes are continuously being created and expanding. Imagine each enormous detonation as a spark igniting another universe, while inflation occurs in different regions, creating countless new universes. This process, in theory, could continue forever. The idea of an endless chain of universes forming and expanding challenges our perception of existence itself. If this process of eternal inflation is correct, then our universe is just a small part of an ever-expanding multiverse, an endless sea of realities, each with its own physical laws, constants, and structures. This concept forces us to reconsider everything we thought we understood about existence. Could it be that new universes are constantly being born, each from the remnants of a previous one? If so, what does that mean for time itself? If inflation never truly ends, then perhaps there was no absolute beginning, only an infinite sequence of cosmic creations, each giving rise to the next. This brings us to an even more profound question. Is our universe cyclical? Some cosmologists suggest that the universe may undergo a repeating pattern of expansion and contraction. In this view, what we call the Big Bang may not have been the first, but simply one of many in an eternal cycle. The idea of a cyclic universe, sometimes referred to as the Big Bounce theory, proposes that before our Big Bang, there was another universe that had previously expanded and then collapsed under its own gravity. This process could repeat infinitely, with universes being reborn again and again. If true, then rather than asking what existed before our universe, we should be asking, what came before the last cycle? Other scientists propose an even stranger possibility, one where time itself may not have always existed. Some theories suggest that time, as we perceive it, may have emerged only after the Big Bang. Before that, there may have been a timeless state, something beyond human comprehension. If time had a beginning, then before the Big Bang might be a meaningless concept. This notion aligns with certain interpretations of quantum mechanics, where particles can exist in superposition, seemingly outside of time. Could it be that the entire universe, before the Big Bang, existed in a quantum state, undefined, undetermined, and only brought into existence through some yet unknown process? Some physicists argue that our universe could have emerged from a quantum fluctuation, a random event within an overarching quantum reality. In this view, universes are continuously forming, each arising from the vacuum energy that permeates existence. This would mean that our universe is not unique, but just one of many quantum possibilities, popping in and out of reality like waves on an infinite ocean. As we push further into these theories, we begin to see that the very nature of existence is far more complex than we ever imagined. The question of what existed before the Big Bang may never have a simple answer, if it even has an answer at all. Perhaps the true mystery lies not in the past, but in the infinite possibilities of what could still come. If the multiverse is real, if inflation never ends, if time itself is an illusion, then our understanding of the cosmos is only just beginning. One thing is certain. The search for what came before the Big Bang will continue to push the boundaries of human knowledge. As science advances, new discoveries may bring us closer to uncovering the origins of everything, or they may reveal even deeper mysteries we have yet to imagine. No matter the outcome, one undeniable truth remains. The universe, in all its vastness and complexity, is a place of infinite wonder. Siring others prompts a beguiling thought about a fractal universe, where each new universe may, as a matter of fact, make its own huge explosion. Each universe exists as a substitute autonomous space, unaffected by the others. Thinking about the quick advancement of space for specialists, this speculation is both elating and disturbing, as it proposes a relentless multiverse with no unmistakable start or end. Envision our universe being only a smidgen in a giant, unlimited arrangement, continually creating and consistently making new universes. And imagine, what if that is the real essence of reality? There is no before or after, but rather an undying pattern of universes forming. How we decipher nothingness changes when we consider quantum field theory. As exhibited by this theory, the universe isn't simply a blend of matter drifting in space. Rather, it's a complex association of energy fields that fill the universe, cooperating to create everything we observe. These fields are like immaterial oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still dynamic. Particles can appear and disappear within these fields, momentarily gaining energy before returning it. This characteristic prompts the concept of virtual particles, substances that instantly exist and then vanish, leaving only a faint memory of their presence. The thought of virtual particles challenges the credibility of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you, in fact, have nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain dynamic, sometimes creating transient particles. This constant activity in what ought to be nothing suggests that the universe doesn't conform to our idea of emptiness. The fields and forces persist, filling the universe with intrinsic energy that prevents absolute nothingness. This realization raises an intriguing question. If fields create particles and particles create matter, could the universe itself have emerged from this so-called nothingness, infused with quantum fields? Dark energy is an enigmatic force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to certain perspectives, the fact that dark energy exists today could be a lingering effect of an energy field from before our universe's development. The properties of dark energy seem to suggest a massive, hidden force that may have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, might have fueled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that even if our universe were emptied of all matter and radiation, this force would continue shaping the fabric of space-time. This idea leads to an unsettling question. If dark energy existed before the Big Bang, could it have ultimately created the conditions that led to our universe's birth? Could dark energy be the silent architect of expansion, or even the true origin of our universe? As we explore this possibility, we face the idea that dark energy is not merely a force shaping our cosmos, but could also be a key to unlocking the mysteries of the multiverse itself. Another hypothesis, cyclic cosmology, offers an alternative to the Big Bang as a definitive beginning. This theory suggests that the universe undergoes massive cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event, but part of an eternal cycle, where universes expand separately and then collapse into another cycle of rebirth. This theory implies that our universe may have been resurrected from the remnants of a previous one. The cycle of contraction and expansion, repeating endlessly, means that there was never a true beginning, only an eternal sequence of universes arising, evolving, and regenerating themselves over and over again. Cyclic cosmology raises profound questions about time itself, proposing that time may not progress linearly, but instead repeat in cycles. If this theory is correct, it could mean that what existed before the Big Bang was simply another form of the universe, one that collapsed only to give birth to our present cosmos. For scientists, this hypothesis offers a compelling answer to the question of ultimate origins, suggesting that the universe has always existed in some form, transcending our conventional notions of time and existence. Gravitational waves provide another fascinating avenue that could shed light on what existed before the Big Bang. First detected in 2015, these waves are ripples in space-time caused by immensely massive objects, such as black holes or colliding neutron stars. These waves can travel vast distances, carrying information about the events that created them. Could gravitational waves reveal clues about the birth of the universe? Some physicists speculate that gravitational waves originating from before the Big Bang might provide insights into the state of the universe before inflation began. These waves, if detected, could hold imprints left behind by events beyond our current understanding. Their presence could hint at a grander structure beyond what we currently recognize. Just as the discovery of the Big Bang reshaped our view of the cosmos, what if these waves reveal the remnants of a past universe or an event that occurred before the Big Bang? As scientists continue to probe the deepest reaches of space, the question remains, what existed before the Big Bang? With modern theories pointing toward quantum mechanics, multiverses, and cosmic inflation, it seems we are closer than ever to uncovering the profound mysteries of the universe's origins. While the ultimate answer remains elusive, our understanding of what preceded the Big Bang continues to evolve with each new discovery. As we explore these theories, we may find they interconnect, forming a bigger picture, the true nature of existence itself. Until then, we are left with the mystery, pushing science and imagination into realms far beyond what we have ever known. If the nature of the universe is cyclic, or if it emerges from quantum fluctuations in an eternal multiverse, then our perception of a singular beginning may be flawed. Perhaps what we see as the Big Bang is only a transition, one of many phases in an infinite cosmic process. The idea of an eternal, self-sustaining cosmos leads to deeper philosophical questions. If the universe has no true beginning, does it have an ultimate purpose? If time itself is cyclical or emergent, then what does that say about our experience of reality? Could time be an illusion, a byproduct of the way our consciousness perceives change, rather than a fundamental property of the universe? Quantum mechanics further complicates this picture. According to quantum theory, particles do not exist in definite states until observed. They exist in a superposition of possibilities. If this principle applies on a cosmic scale, then perhaps multiple universes exist simultaneously, each in a different quantum state. The act of observation, the measurement of reality itself, may influence the structure of our universe, shaping its evolution. Some physicists propose that our universe is just one of many in a vast quantum multiverse, where every possible outcome of a quantum event creates a new branch of reality. In this view, there is no singular universe, but an ever-expanding tree of possibilities, each branch representing a slightly different version of history. This leads to a fascinating idea. What if the Big Bang was not the beginning, but merely the moment our particular branch of reality became distinct? If so, then before the Big Bang, there may have been a nearly infinite number of alternative realities, existing in a superposition, waiting for a quantum fluctuation to set them apart. Could there be echoes of these alternative paths within our universe? Some scientists believe that anomalies in the cosmic microwave background radiation, the afterglow of the Big Bang, may hint at interactions with other universes. These anomalies could be the fingerprints of previous cycles, traces of cosmic collisions, or signs of quantum entanglement across different realities. As our understanding of physics deepens, we may discover that our universe is not the ultimate reality, but one piece of a much larger puzzle. String theory, for instance, suggests that additional dimensions beyond our perception may contain other universes, parallel to our own, yet hidden from direct observation. These dimensions might be the key to unlocking the true structure of the cosmos. If higher dimensional spaces exist, then the concept of before the Big Bang may be meaningless. Time itself may be an emergent phenomenon, arising from the way energy and matter interact within our universe. In this scenario, the laws of physics that govern our reality may not apply in the same way beyond our universe. What we see as the beginning may be just a localized event within a much grander, timeless structure. One of the most profound implications of these ideas is the nature of consciousness itself. If the universe is shaped by quantum processes, and if quantum mechanics suggests that observation affects reality, then what role does consciousness play in the formation of the cosmos? Could the act of perceiving the universe be as fundamental as the forces that govern it? Some theories, such as panpsychism, propose that consciousness is not a mere byproduct of matter, but a fundamental aspect of reality, present at every level of existence. If true, then perhaps the universe itself is conscious in some way, a vast, self-aware entity that continually evolves, learning and adapting through the creation and destruction of worlds. If consciousness is deeply connected to the fabric of reality, then perhaps our role in the universe is more significant than we realize. Maybe our ability to question existence, to seek knowledge, and to ponder the origins of the cosmos is not just an accident of evolution, but an intrinsic part of the universe's unfolding story. Ultimately, the question of what existed before the Big Bang may lead us to an even deeper mystery. What is the nature of existence itself? Is reality an endless cycle, an infinite sea of possibilities, or something beyond even our most advanced scientific theories? As we continue to explore the frontiers of physics and cosmology, we edge closer to answers. But with every discovery, new questions arise, reminding us that the greatest mysteries of the universe may never be fully solved, only understood in ever-deepening ways.